Welcome to Try It 5. In this tutorial, we're going to explore ideas around distributions and sampling. We're going to keep working with continuous data. We're going to use the data set of the Academy Award winners for Best Actor and Best Actress. We're going to be looking at their age of award. We're going to be exploring those distributions. We're going to introduce a new tool today. So we're going to be looking at a visualization tool that was created right here on UC Davis. It's called See It. For this part of the tutorial, we're just going to be focusing on one variable, just their age at award. We have a list of all of the people who have won the Best Actor in a Leading Role and the Best Actress in a Leading Role Oscars. So that's an entire population. That's every member of that population. We're going to be exploring some ideas around sampling today. So our driving question today is really about how closely does a sample represent that population and what influences whether that sample represents that population. Let's go get the data. The data is stored in Google Docs. Here's the data set. Let's use Command A to select all, Command C to copy, and then we're going to open up a new Excel workbook and paste the data there. So we want a new blank workbook and Command V to paste. So there's our data. I'm going to practice my good habit of preserving the raw data. So I'm going to immediately just make a copy of it. I'm going to come down to Insert a Sheet and Control V again to paste it again. I'm going to name my sheet 1 raw data. And name sheet 2 visualization. Now we're going to open the tool See It. It's available on the web, it's free, it's open. There's a link in the tutorial. There's a link on the website. So let's follow that link and open See It. See It's a great tool for exploring the data, for really looking at how it looks and to practice our visual reasoning skills. As you can see, there are some data sets already loaded into See It, but we're going to load our own because we want those ages at which the actors and actresses won the Best Actor and Best Actress. So we're going to come down to the bottom left and click the plus sign to add a data set. So let's go get the data. I'm going to pop back to Excel and I'm going to click on the entire column H to highlight it. So I clicked at the gray H at the top, Command C to copy it. You can see the answer active. That means it's ready to be copied. I'm going to switch back to See It. On this page, I see that I need to enter a title and that I need to enter data, and that enter data set text is already highlighted. So that's where I'm active at the moment. So if I just Command and V, it's going to go ahead and paste right there. So it's pasted that column of data right into that dialog box. Let's give it a title. Now, do we need to say that the first column is a label? No, we've only got one column, so the first column isn't a label. Those are the only options that we've got on this page. So let's come down and click the Load Worksheet from Form. Now it's giving us a warning that it's only going to be accessible for this one browser session, that we're not really adding it to the See It databases. We're just uploading it for right now. That's great. And down at the bottom of the data sets, you can now see that we've got Academy Awards. Let's look at our data. I'm going to click on that triangle next to the title we gave this, Academy Awards. I see my one variable, age in years, is listed. There's a pencil, a trash can. If I click on the pencil icon, it pops up the data set. You can just check that it's there. So let's see it. We've got this workspace over here on the right that's at the moment called empty graph. Well, let's fill it. I'm going to click and drag on the title of my variable and drop it into that graph. And what's it done? What have we got there? There's a little blob for every member of that population, every member of that data set. It's allowing us to visualize that distribution. Age in years is a continuous variable. It's measured in numbers along a continuum. Let's put our x-axis down there. We've got all of the ages of each individual, ranging from the youngest through the majority up to the oldest. And you can see each one of those is representing a particular member of our data set. To explore this data, to look at some of the descriptive statistics, we're going to come up to the top left corner and click on the wrench. And it's asking us, do you want to group your data? And let's start by saying those 4 equal groups, quartiles. So our N, our population size is 176. You can see that's written down there. So it's divided that by 4, and it's decided that it needs 44 people, 44 observations in each quartile. And so it's showing us how much of the scale is needed in order to contain a quarter of the population, a quarter of the observations. What you should be seeing here is you should be asking yourself, do these look symmetrical? Do they look even? Does it take the same amount of space regardless of where you are on the scale? Or are some of them highly concentrated and so they get a quarter of the observations with a very small amount of the scale, while some of them are really dilute, some of them are really spread out, and you need a whole big piece of the scale in order to get a quarter of the observations. Let's look at some more of our descriptive statistics. We're going to go up to the wrench. We can add some of these measures of central tendency. Let's start with the mean and the median. So we've got a red line that's telling us the mean. If the word mean and the number didn't pop up above that, go ahead and click on that square and that turns it on and off. Same for the median. So these are 2 of the measures of central tendency. They're telling us the number around which all of the other numbers cluster. You can see that the median is right there on that central line because the median is the number that is halfway through the observations. So half of the observations, 88 of them, are below the median. Half of the observations, 88, are above the median. The mean is a little bit higher on the scale. It's been dragged towards these outliers. See, it's going to let us create frequency distributions and histograms as well. Let's take a look at that. I'm going to come up here to where it says advanced mode. It's kind of gray, so it doesn't encourage you to click on it, but you can go ahead and click on it. And now it's red and you're in advanced mode. Let's go back under that wrench and see what other options we have in advanced mode. Let's explore this fixed interval width. So what this is telling us is it's going to create roughly a histogram where it's going to have a fixed interval, regular amounts of the scale, and then it's going to count how many observations are in each of those fixed intervals. Let's reduce the interval width. Let's pop it down to 5. I'm going to go ahead and set the minimum to 20 so that those are at nice, even intervals. And I want to see these numbers, not just as numbers, but as height. So I'm going to choose to show the histogram. Here we have a histogram of this population where we have set it to fixed intervals of 5, starting at 20 and moving up. And see it has calculated how many observations fall into each of those groups, and then has drawn us this histogram to display that data. What happens if we set the interval even lower? How about if we set it to 1? So if we set it to 1, we've got that fixed interval of 1, so it's 20, 21, 21 to 22, 22 to 23, 23 to 24. And so it's a lot less summarized, it's a lot more detail. This is partly up to you as to what level of summarization expresses the detail appropriately. The larger the interval width that you choose, the fewer the bins, the more clumped together the data. We have our measures of central tendency. We're seeing our distribution, our histogram. Do you remember the other descriptive statistic that we need? We need a measure of variability, right? Let's first go back and set our groups back to 4 equal. So if you recall, that's these numbers will be equal. There'll be equal number of observations in each group, but the groups won't have the same intervals. So we're now looking at the difference in the intervals. And back under that wrench, I'm looking for a measure of variability. We were calculating standard deviations. So I'm seeing this abbreviation SD here, and I bet you that's what we're looking for. Let's click on the word box, or the option for box plot. Did you see what it did? Let me go back to 4 equal. So 4 equal and box plot. Jump back and forth a couple times between those and see if you can explain what it's doing. Where is the box in the middle being drawn? What are the edges of that box? They are exactly around the middle half of the data. So if we divide it into 4 equal groups, we've got a quarter down here, and then half in the middle here, and then a quarter up here. When we draw a box plot, we draw a box around the middle half of the data, and then we extend these whiskers down to the minimum and up to the maximum. Now with a box plot, you're looking at whether or not it is symmetrical, at whether this whisker is as long as this whisker. And you can see in this case, it's clearly not symmetrical. One thing that's a little bit counterintuitive is that a long whisker actually means fewer observations. So a quarter of the observations are up here, but they're spread out all the way along that arm, along that whisker. A quarter of the observations are down here, and they're tightly concentrated in that whisker. I'm going back up to the wrench. I've chosen my box plot, but I want to add standard deviation. And so it's now calculating for us the standard deviation, and it's got it there at 11.1.